Well, it's a real pleasure to be here today. And I really want to highlight the degree to which the work we do at Berkeley is a team effort. And so my laboratory has postdoctoral fellows and students from the United States, from Chile, Colombia, Kenya, Nigeria, the Navajo Nation. And without the partnerships that that group builds, we couldn't get the type of sustained, substantive work on sustainability done that we're able to do on a regular basis. And that's really a hallmark of why it's so great to be here. In terms of my own work right now, our laboratory is really focused on the various efforts that make the so-called Paris Climate Accords, this 2-degree pathway, real. And we do this at a variety of scales, and today I want to highlight a number of those features. And so, in brief, the Paris Climate Accord is a global partnership where each country committed to reduce its emissions. And essentially, so far, we have about a degree of global warming that countries have committed to avert. And that's really the pink slice of this pie, where each country's INDC, or national commitments, have brought this number down. In fact, at the waning days of the Obama administration, the so-called Kigali Accords were passed that cut about another ½ degree off. And so our lab is focused on making those commitments verifiable and real and working at the science and policy level to verify and to sustain those commitments. The second part of the story, though, is that the gray area, going from about 3 degrees of warming to the 2-degree ceiling we want to achieve, requires the integration of basic science, of renewable energy, of smart energy systems, of storage, with the fossil fuels that we're committed to use for the near future, and put that into a package. And our efforts are really designed to put that all together in systems that can be used from households to communities to nations and regions. In fact, we're truly blessed to work in California, where those efforts are, in fact, part of the state policy. And if we think about this as a cartoon, this box of emissions, this 830 megatons of emissions, is what California would have been emitting in 2050 if we didn't embark on this path. Not only does California have a very strong pathway to meet these targets that our lab has worked hard to build up, but we also have a strategy step by step. And so in California, there's an effort to be incredibly efficient, both in terms of the transportation efficiency and electricity for our homes and buildings. That's represented by crushing that box of emissions in on either side. But we also have learned that we're going to have to critically shift ourselves towards electricity, away from all liquid fuels, both fossil and biofuels, to meet this dramatic 2-degree C target, or about an 80% reduction in emissions. So we crush the box, then we shift it over to the right, one of the good shifts to the right, and then what we do is we crush down and select cleaner and cleaner fuels through a variety of measures. And our laboratory here at Berkeley has been instrumental in helping to design those policies in conjunction with state regulators. That overall gives us this 80% reduction that we need. The efforts that we've built in California have also been part of partnerships around the planet. And so this map shows the current places around the globe where our team in my laboratory at Berkeley has worked with local governments, academic groups, industry, and think tanks to build what we've called the switch model. And it is a model of the power system that allows us to think through the impact and the benefits of emphasizing solar with storage, batteries with smart systems in buildings, the value of smart sensors and other technologies. Our efforts in California spread across Western North America. We have teams in place and partnerships in Chile, in China, in Kenya, in Mexico, and all these efforts have really built up a database of how these systems can be worked together. But that wouldn't be the whole story. If that wasn't hard enough, the fact that about 1.3 billion people on the planet don't have access to even basic electricity makes this job even harder. And in fact, the forecasts are that by 2030, we won't have changed that number much at all. So our laboratory has been involved in efforts to design better cook stoves, but also to produce the first field-based study ever to understand the so-called dose response, or the impact analysis of changing to cleaner stoves. We do that by studying everything from the fuel mix to the emissions themselves, to some novel ways to bring those technologies to life, such as our Rapper star here, describing cook stoves that can also power cell phones and radios and things. This effort, this marriage of information technology and energy systems, has been a hallmark of our efforts that have now led to the fastest increase in energy access in the world, which is in East Africa, were so-called pay-as-you-go technologies, small solar and other devices tied into mobile payment systems with smart, secure mobile money, has allowed us to dramatically change the landscape. I've described large utility scale and small end-use scale, but in fact, we're also working at the intermediate scale, the less studied communities, where what we have are places where in Oakland, California, at Berkeley's own Gump Station in the South Pacific, and in rural and urban areas in Kenya, where what we're seeing are community-scale solutions that bring together these technologies with best practices to electrify those that don't have power and to green it for everyone else. Thank you so much for your time.